Hello everyone, this is Unit 8, Lesson 4. Lesson target, I can describe patterns of geometric sequence by using the common ratio, and that's what we're going to be doing. We're going to get right to the do now, which a lot of people have some trouble with. A theater has 35 seats. We are going to highlight 35 seats. That's going to be my A sub 1. In the first row, each row has 4 more seats than the row before it. That's very important. And they're asking which equation represents the number O. So just go ahead and think back and look at the equation. A sub n equals A sub 1 plus the D times n minus 1. And that's the formula that we've been using in class. And if you remember it, that's great. If you don't remember it, that's fine too, because we could do this without the formula. But with the formula, you're going to just label A sub 1 as 35. And then the D, which is the difference, right? And it's the common difference in this case, is 4. So if you're going to use that formula, you're going to have A sub n equals A sub 1, which is 35, plus n minus 1. N minus 1, the way we write it is that the D comes first. So just going to squeeze the 4 in there. And that's D. But just remember, if you don't remember, if you don't remember the formula, then there's a way to do this with just substitution. We have A sub 1 as 35 and D as 4. Just remember that if you label everything as far as the first row goes, the first row is supposed to be 35 seats. The second row, that's A sub 1. And then the second row is supposed to be 4 more than that, which is 39, and then 43, and then 47. You're just adding 4. So if we substitute and we look at the n as, all right, here's the second row, but I'm just going to take the first row. So n is 1. N is 1. So if you're taking the first row, and I'm going to substitute that in right here. This is A sub n. A sub n is A sub 1. All right? Because we're just doing the first row and see if it equals 35. If it doesn't equal 35, it doesn't work for the first row. It's not going to work for the rest of them. So A sub 1 and it equals 35. I'm just copying down this, plus the n, which is the first row, plus 4. So 35 plus 5 is 40. That is not the first row. It's supposed to be 35 seats in the first row. A sub 1, again, I'm looking for the 35. That is the starting amount. That's the A sub 1. Plus the n, which is 1, because that's what I'm looking for. 1 plus 1 is 2 times 4. This whole section here, 2 times 4 is 8. 35 plus 8 is 43. That is not 35. Let's look at this one. A sub 1 equals 4 times 1 plus 35. That's 39. That is not the first row. Let's take a look at this one and see if it does work. A sub 1 is 35 plus 1 minus 1 times 4. So this is 0 times 4. This is 35. That works. Let's see if the second row. A sub 2 now is 35 plus 2 minus 1 times 4. It's 35 plus 1 times 4. That equals 39. And yeah, 39 is the second row. If you did it for the third row and the fourth row, it would work. So basically what you do have to remember is the formula. The formula is on the reference sheet, and that's the way you're going to do it. So D is your answer. The thing that we are working on as far as this lesson goes is geometric sequence. And in the geometric sequence, the ratio between the consecutive terms is the same. That ratio is called the common difference, common ratio. So just remember, it's not the common difference, the common ratio. That's the better way to say it. Each term is found not by adding and subtracting. Each term is found by multiplying the previous term by the common ratio. And a lot of times they won't give you the common ratio at all. But in this example that I just have here, 1 goes to 5. You see that 1 goes to 5, 5 goes to 25, and 25 goes to 125. So just make believe that the times 5 was not there, because they're not going to give it to you, and they're going to ask you what the R is. The R is the common ratio. So how do you get from 1 to 5? How do you get from 5 to 25? That's times 5. That's pretty easy, pretty straightforward. But if you don't know the common ratio, say the numbers get a little bit tricky, you divide the second number by the first number. And if you divide the second number by the first number, you will get the R, which is the common ratio. It'll always work out that way because you're multiplying something to get to the second. You're multiplying the first number by our common ratio to get to the second number. You're using that same common ratio to get to the third number and to multiply to get to the fourth number. So if you divide the second number by the first number, you will always come out with the common ratio. So let's get into some problems. Take a look at this one. We are going to write the next 3 terms in the geometric sequence. We have 3, 6, 12, and 24 so far. So we need to get the common ratio. Common ratio is easy in this one. We started you off with an easy question. The term number right here is 1, goes to 3, 2 goes to 6, 3 goes to 12, and 4 goes to 24. You might know the common ratio right now. How does a number get, what is the common ratio being multiplied to get from 3 to 6? This is a geometric sequence. How do you get from 6 to 12? If you said times 2, that is correct. It is times 2. So the R is 2. So just remember my whole thing. If you do not know, you take the second number, the second term, and divide it by the first term. And you will get 2. And that's the common ratio. So 24 times 2 is 48. 48 times 2. And you could use your calculator for anything that you want, like say 48 times 2 is 96. And 96 times 2 is 192. And you could put that in right here. So the common ratio for this geometric sequence is 2. And that's really it so far. So we're going to just focus on a couple of these. It says try these. We're going to work our way through them. Just remember, we're going to go for the R first. So for A, I'm going to put down A here is A. And I'm going to divide 12 and 4, and that is 3. So my common ratio is 3. Then I just take 36, 4 times 3, just check it out first. 4 times 3 is 12. 12 times 3 is 36. Grab your calculator. And you do 36 times 3, which is 108. And then you don't have to just keep on, writing it. Just press times and it'll bring the 108, the calculator bring 108 down, and you just press times 3 is 324. Then times 3 is 972. So when it gets a little bit tricky here, just B equals, just remember it is the second number divided by the first. So this is 9 divided by 18. 9 divided by 18 is 0.5. So the R, as soon as you put that down, the 0.5 is your R. And then you can go back to the calculator, just make sure that 18 times 0.5 is 9. times 0.5, you could just put 0.5, is 4.5 times 0.5 is 2.25. That's correct. Times 0.5. You're multiplying by a half, so the number should get smaller. And then times 0.5 should be a nice small number, 0.5625. And then one more, times 0.5, and you get 0.28125. And that's it. So C, I'm going to do -6, the second number divided by -6, the first number, divided by 2. And that is -3. So I'm just going to put as the R as -3. And I'm going to, like, obviously 2 times -3 is -6. -6 times -3 is 18. And that's it. So I'm just going to put -54 times -3. It should be a positive number. It is 162. 162 times -3 is -486. -486 times -3 is 1,458. And that's it as far as common ratio goes. Try these on your own. Just press pause and then come back and just look at my answers. Okay, I just wanted to make sure that you did get those final answers right there. I got the common ratio of 3, common ratio of 0.25 for E, and common ratio of -0.5 for F. And those are the answers. All right, just remember, take the second number and divide it by the first to get the common ratio if you can't tell right off the bat. Like a number like A is pretty easy to look at. It's 4 to 12, and obviously it's 3. But something like 64 to 16, you have to take, to get that, you might have to take 16 divided by 64, like I did down here, to get 0.25 as the common ratio. All right. So it's the graph the geometric sequence, which is 32, 16, 8, 4, and 2. And then plot the ordered pairs and A sub n. And it's asking, what do you notice after you plot your points? So I'm going to put these numbers here, 32, 16, 8, 4, and 2. So the common difference, the ratio, the R, right, the common ratio, is, it goes from 32 to 16. So I'm just going to go 16 divided by 32. And you do get 0.5. So the R is 0.5. So this is when you are multiplying, that's multiplication of 0.5, 0.5, 0.5, and 0.5. So let's go ahead and graph this. So this is 1 and 32. That's all the way up here. 2 and 16. That is here. 3 and 8. Right here. 4 and 4. Which is right here. And 5 and 2. Which is right here. So this is a curve going down. So we're just going to go like this. Make our best curve down. Like that. And remember, it does not touch the x-axis, just like that. And what do you notice after you plot your points? So it's basically saying because the consecutive terms of a geometric sequence change by equal factors, meaning that it has a ratio that is the same, the common ratio, that are the points of any geometric sequence with a positive common ratio lie on an exponential curve. So it's a curve going downward instead of something like maybe going up. All right, so just remember a geometric sequence shows an exponential pattern. And that's it for that page. Just going on the explicit formula of a geometric sequence, you could use the first term. This is the explicit formula. It is given on your Algebra 1 Regents reference sheet, and you could use the first term and the term number, and the common ratio to find the value of any given term. So take a look, and I'm just going to go over this formula with you. And again, they give it to you. So a sub n is the nth term. That's a sub n. A sub 1 is the first term. And then r is the common ratio. And then n minus 1 is the term number. And an explicit formula is one that you do not need to know the value of the term before the term that you're trying to look for. So that's why this is very, very handy, because remember, a geometric sequence has that common ratio, and that means you don't need the term before it. So you could just get any term as long as you have enough information that you could substitute in. So like I said, you only need the first term and the common ratio and the term that you're trying to find. So let's get into some questions, and I'll show you how this works. So Regents test prep. So find the fourth term of a geometric sequence for which a sub 1 equals 7 and r equals -1/5. Just remember what a sub 1 is. A sub 1 is the first term. And then r equals the common ratio. So you're just going to find the fourth term without knowing any of the third term. So you only know the first term. So you just look up that formula for geometric sequence and you just write it down. A sub n equals a sub 1 times r to the n minus 1. So a sub n is the term that you're looking for. So I'm just going to put down a sub 4 is the term that I'm looking for, equals a sub 1. A sub 1 is 7. 7 times r, which is -1/5. And then n minus 1, which I'm going to put parentheses around this and parentheses around this because that's the way I kind of like to do it. It's n minus 1, so you're looking for the fourth term, minus 1. Now you grab your calculator and you are going to put this in. And once you have your calculator set up, you're going to open the parenthesis and put 7 in, and open the parenthesis again, put alpha x. Alpha x is the fraction symbol, or however you get to the fraction symbol. It's -1/5. And press to the right to get away from the denominator. And then another parenthesis, a closing parenthesis. 4 minus 1 is 3, so I'm just going to put the 3 there. Right, and you press enter, and you will get -7/125 as the fourth term. And that's it. All right, what is the common ratio? Another type of Regents question. They're just asking for the common ratio. So this is a little bit easier. of the geometric sequence shown below. Since you know it's a geometric sequence, all you have to do, and it's just basically multiplication, all you have to do is divide the second number by the first. So 4 divided by -2, you could check it in your calculator, is -2, and that is it. Which of the following could not be a term in this sequence? So looking for like something that could not work. So I tell you, this one, like they're giving you the formula right here. So it is a little bit, I know it's a little bit confusing, but all you're doing is substituting numbers in, right? So they're looking for answers. So I substituted 1 in. So it's 2 to the first power minus 1. 2 to the first power is 2. 2 minus 1 is 1. That could work. So I don't know why I circled it, but this works. Because they're looking for one that could not be a term. So this works. So that works. It cancels out. So now you just remember, 2 to what power minus 1, it like has to be equal to 31 for this to work, for B to work. So you just pick up your calculator and you start doing 2 to what power. So I did 2 to the 5th power. 2 to the 5th power is, let me just erase this for a second. And again, that's not working. All right, so if you do a sub 5, let's just say, I'm just taking numbers. So if you do a sub 5, that means it's 2 to the 5th power, because that's n, this is n, you're substituting n. 2 to the 5th power is 32. 32 minus 1 is 31, so a sub 5 would be 31. So this works. This cancels. So now we're looking for one. Well, let me just jump to 63 because they go out of order here. So 63. So you're looking for 2 to what power minus 1 equals 63. So let me just bring up my calculator again, and I did that. 2 to the 6th power is 64 minus 61 is 63. So let me just see that again. That is to the 6th power. So a sub 6 is 2 to the 6th power minus 1, and that is 63. So that works. I don't know why I did that. Now, just by process of elimination, I'm looking for an exponent of 2 minus 1 that will equal 127. So I'm just going to grab my calculator and hopefully find it. So 2 to the 6th is 64. 2 to the 7th, I'm just going to go up the ladder there, is 128. So 2 to the 7th is, so we're going to put 7 here. So 2 to the 7th is 128 minus 1 is 127. So a sub 7 is 127. So this works. Let's see if 512 works. All right, there's only one number left, but you never know here. So now 2 to the 8th power, I'm just going to go up, is 256. No, 2 to the 9th power is 512. Okay, so 2 to the 9th power is 512. So we have a sub 9, because that's to the 9th power, equals 2 to the 9th minus 1. So a sub 9, and I'll write this down, is 512. 2 to the 9th is 512 minus 1 is 511. So a sub 9 is 511. This one does not work. Not work. So that's your answer. That's how I would do it. Just basically when they're giving you 2 to some power, just figuring out powers and then minus 1, that would be kind of easy to do. Or you could just put this into the calculator. All right, I didn't even think about that, but just go and press Y equals, and I'm just going to put this directly in. which could not be a term in this sequence. This one I like better. So we're going to have 2 to the x power and then minus 1. So we're going to press second function graph, and here we go. Here's all of our numbers for that. So which one works, which one doesn't work. And now you don't have to worry about actually doing what I just did, like by hand. So 1 is a term. 31 is a term. You see it there. 63 is a term. Then if you bring it down, it's 127 is a term. And then 512 is not a term. So I think actually just put it into the calculator. And I didn't even think about that until I was finished with the problem. All right, so again, they're just asking you for the common ratio, so it's not difficult, right? You take the second number and divide it by the first. So I'm just going to write it this way. Right? Grab your calculator. See a pattern here. You could definitely see that we need the calculator, and it's easiest to use the calculator all the time for every single question. So we have alpha x. We're going to divide that by 3 over 4. And we're going to divide that. We press division. And negative 1/2. So we're going to have negative 1 over 2. And we press enter, and we get negative 3 over 2. The calculator gives us the answer. We can't go wrong. Regents question. All right. Calculator question completely. All right. What is the common ratio of the sequence whose first term is 27? First term is 27, geometric sequence. And fourth term is 64. All right. So when they do ask you a different question like this, we're just going to say, okay, they're looking for the common ratio, right? We don't have the second term. If we did, it would be an easy question. So we're just going to, this is still an easy question, but the thing is, we're just going to use the common ratios to get to the number. But I'm just going to tell you, if it goes from 27 to 64, it has to be a number that is greater than 1. And there are 2 choices here that are less than 1. And you can cancel out this one and number 4. No, I'm sorry. Number 4 is greater than 1, and number 2. Because 64 over 81 is less than 1. That means the numbers, if you multiply, if that was the common ratio, it would be going down. Instead, it's going up. So I'm going to take 37 over 3. That is way too large. I'm going to cancel it out right now, but I'm going to try 4 over 3 here. So I'm going to grab my calculator, and I'm going to go and put in that first number, which is 27, times, and I'm going to do 4 over 3 and see if that kind of works. So that's 36. Now 36 times, I'll do the same thing, 4 over 3. I just want to check it to see if I'm correct. That's 48. So that's 48 right there. Then I'm going to go times again for the final, and hopefully this will equal 64. And it does. So we figured out our answer, and 3 is our answer. 37 over 3. The reason why I didn't pick 37 over 3, just doing the math in my head, 37 divided by 3 is a very large number. It's 12.333. For that to be the common ratio, if you do 27 times 12, it's already going to be over 64. So that cannot be the answer. See how like these questions, they do they have a little bit of a difficulty to them, but if you use common sense, Like, you could see what the answers are. Definitely, you could cancel out 1 and 2 for that question. Here's a challenge question. What is the common ratio in this sequence? So we're going to go from, right now, I just want to figure out what the number that's being multiplied to get to -3 over 32 from 1 over 64. So I'm going to take the calculator out again. And I'm just going to divide those two numbers because remember I'm taking the second number, dividing it by the first. So -3, let me just go back and just do alpha x, and it's -3 over 22. No, it isn't. It's not over 22. It's over 32. So I'm going to clear that out. Almost made a mistake there. 32. Divided by 1 over 64. And it's -6. So the numbers -6. So we see as -6, I see this one and I see this one. -6. This is number 3 is -3, so that's out already. This right here is -3 over 2, that's out already. All right, so now we take a sub 3, I'm sorry, a to the third, and divide it by a to the fifth. So that equals a to the -2nd. And then you could flip it to 1 over a to the 2nd. So that one right there is a to the 2nd on the bottom part of the fraction. There's no a to the 2nd on the bottom part of the fraction. 2 is my answer. But just take a look at the b, and if you did do b to the 4th divided by b to the 3rd, that would be b. All right, and that's about it as far as that goes. But just remember, if you're multiplying a to the 5th times some number will get to a to the 3rd, it's a to the -2nd. B to the 3rd times what number equals b to the 4th? It's b. B to the 3rd times b equals b to the 4th. So that's a challenge question, and 2 is your answer. All right, critical thinking. Go ahead, try to do this. Read the question. See if you could do this. And we'll come back. Press pause and try the problem now. The first thing I did here was that Kara exercised the 2 minutes for 2 minutes in the first week, 4 minutes for the second, 8 minutes in the third. So just if you're looking at the numbers, you know what the R is, or you should know what the R is. The R is 2, right? And that's the common ratio. Common ratio is 2. Now it's asking you if describe the sequence. What's common ratio of 2? It's a geometric sequence. So let me just put that down. With a common ratio of 2. Will she be able to continue this pattern as she increases her exercise time? And no, she will not be able to continue that pattern, because there's no way the next increase of multiple of 2, I'm sorry, 32 times 2 is 64. And then 64 times 2, it would be a larger number. And then that number times 2, and then that number times 2. She can't keep it up. There's absolutely no way. So she will not be able to continue this pattern. It would just be too much exercising, and you're not going to exercise if you're increasing by your exercise time by multiples of 2. All right, so you're timesing 2 every single time. It's impossible. And that's it. She will not be able to continue the pattern because the exercise time would grow to an unrealistic total time. So going on to the explore, again, find the common ratio of the sequence and then go ahead and see if you can get those answers. Move on to number 2. Try the first 2 on your own and, come back after you press pause and try the problems now. So just simply put, like for number 1, just find the common ratio, how to get from x to 2x. We're talking about the r, right? R equals whatever that is being multiplied, that first term, x times what equals 2x squared. So I did 2 divided by 1. Let's take the numbers first, and it's 2. So obviously this is out and that's out. Then x squared divided by x is x, so 1 is your answer. And that's it. That's all you have to do. Find the common ratio of the geometric sequence where the first term is 5 and the third term is 245. So we're just going to put 5 down and then a blank because we don't know that second term, and then this one. So the way I would do this is to just realistically just take the small, look, you're trying to find a number that is multiplied by the term prior to get to the next term. So 5 times 7. So you just take this one first. Just take this first number, 5 times 7. So we're just going to do 5 times 7. And that's 35. And then 35 times 7. 245. Done. Answer. Because it's times 7 times 7. Easy. 5 times 49. Look, it's too large. 5 times 49 would be 245 already. That's out. Anything larger would be unrealistic. But think about what you're doing before you go and pick an answer. In the geometric sequence, the first term is 4. The common ratio is -3. So the first term is 4. So we have a sub 1 equals 4. Then we have the common ratio, which is r, is -3. That is all you need. All right. Honestly, you could do this without the formula, but you do have the formula. So this is a sub n equals a sub 1. And I'm just going to put that in parentheses. And then r to the n minus 1. All right. And actually, that n minus 1 probably be better on the outside. Whatever r is to the n minus 1. All right. So a sub n, we're trying to find the fifth term in the sequence. So, and a sub 1 is the 4. And then r is -3. So we're trying to find the fifth. So 5 minus 1. So I know that this is 4 times -3 to the 4th. All right, so 4 times -3. I don't know why I put that down already. So we're going to have 4 times the -3. And then it's to what power? To the 4th power. And we have 324. But honestly, this, I mean, really, you could go ahead and actually just draw the lines. All right, so the first term is 4. The second term, the third term, the 4th term, and the 5th term is what you're looking for. So if they say that the common ratio is -3, then 4 times -3, 4 times negative 3 is negative 12. Then you do times negative 3 again, and negative 30, positive 36. Then you do negative 3 again. Then you do negative 3 again. You'll eventually get to 324. So you could do this by hand without putting it into the formula, but there it is. All right, so a sub 1 is 6. So a sub 1 is 6. A sub 2, what does that equal? So what I'm doing is I'm just taking this. You see this? A sub n equals 3 plus 2 times the a sub n minus 1 squared. I'm just going to rewrite it, and I'm going to put a sub 2, since we're looking for a sub 2 instead of the n. So a sub 2 equals 3 plus 2 times a sub 2, because n is 2, that's what you're looking for, minus 1. Right here is the prior term, right? The previous term. So I'm just going to rewrite it again. A sub 2, this is the reason why they give you a sub 1 is 2 times the a sub 1 times squared. So a sub 1 is, and they gave it to you, a sub 1 is 6. 3 plus 2 times 6 squared. Now you grab your calculator. And one more time, let's see. And you put that directly into your calculator. 3 plus 2, just like it is, 6 in parentheses squared. And you will get 75. These are easy questions. You could do these. It's not as difficult as it seems. And those are 4 Regents problems, Regents type problems. So here's your exit slip. Go ahead, try all of these problems, and then we'll come back and we'll kind of review what you did. Try them, press pause now. So for the first term, first question in the exit slip, very easy. You're just finding the common ratio. I did negative 12 divided by 3. Negative 12 divided by 3 is negative 4. 48 divided by negative 12, if I tried it again, is negative 4, and it works out perfectly. Number 2, I took 764 divided by 7640, 7,640. Then you get 1 over 10, or you could put it down as 0.1, which is the decimal equivalent to 1 over 10. So a little bit more difficult right here is what is the geometric sequence? What is the 9th term? So we're just going to highlight. We're going to highlight. And it's geometric sequence where a sub 3 is 81 and r is 3. So what's that 9th term? So I am just going to go ahead and see if I can put down all the terms like this, right? This is 4, this is 5, this is 6, 7, 8, and 9. What is the 9th term? So a sub 3, so this is a sub 1, this is a sub 2, a sub 3. A sub 3 is 81. All right, and they want the 9th term. This is a sub 9. And honestly, what I would do for this one is just go ahead and times by 3. Just do 81 times 3, and you do get 243. So that's a sub 4. A sub 5 would be 243 times 3 is 729. That's a sub 5. A sub 6 is times 3 again. Would be 2,187. A sub 4, a sub 7, 6, 7 is times 3. 6,561. And a sub 8, we're almost done, times 3, 19,683. And then one more time, times 3, would be 59,049. That's how I would do it. So a sub 9 equals 59,049. And before we finish this up, I just wanted to show you that you could use the formula, but you would have to go back to the first term. All right, so because you need, the formula is a sub n equals a sub 1 times r n minus 1. All right, to the n minus 1 power. So you do need a sub 1, and they give you, on purpose, they give you a sub 3. So if it's 81, and 81 times 3 would get you to 240 to the next term. If the common ratio is times 3, that means you would have to actually divide by 3 to get you back to 27, and divide by 3 to get you back to 9. So once you had that first term, then you could go ahead and use the formula. You're looking for the 9th term. So on down here is a sub 9 equals 9 times 3, 9 to the 9 minus 1 power, and you would get the same answer of 59,049. And that's about it. Okay, that ends our lesson on geometric sequence. Hope it helped. Thank you for watching. See you next time.